Welcome everyone to our cluster call in 2026. We haven't had this call last month because of the ESIP January meeting. And in the last month at the January meeting, we focused on the model context protocol with the idea that MCP can be a powerful tool for users to interact with the data. And so we have seen some of the demos and also some basic introduction to the MCPs. And today we have presenter Dr. Anthony Kougkas from Illinois Institute of Technology. And he will be giving a presentation from storage optimization to context orchestration, context engineering for environmental data systems. And we will have time for discussion with Anthony after his presentation. And if we have more time, we will do a recap of our general meeting session, also move ahead with planning for our updates to the checklist as well. Anthony, the floor is yours.
Thank you, Douglas, and thank you for your patience in coordinating the emails with me. We had a change in the institution from Google to Microsoft, and we lost a lot of emails, but hey, here I am. Thanks for the invitation. Lovely to be here. It's my first time in this community. So I don't know exactly like your community directly, but I'll be happy to present some of the stuff we're doing and how are they connected to the kind of bigger agentic AI era. A few things about me. I've been doing HPC for more than 13 years now. I come from this older kind of MPI supercomputing world with storage and parallel file systems, and I've done work with like buffering at distributed scales, and we kind of worked on the concept of data tiering with the new advent of hardware like NVMEs and other deployments across distributed environments. We have developed in the last 7 years pretty good IP around data tiering and management at scale. Some of the partnerships and some of the things I'm showing in this presentation are a culmination of years of research across multiple projects. I do have one project I'm going to kind of pitch in here and kind of plug in our own work. But things have been community driven for a long time. I am a professor at Illinois Tech. I'm not a tenure professor. I fundraise for my own salary and my team's salary. I lead 20 people. I have 12 PhDs, 6 faculty, and 3 engineers, maybe even more now. And so I come from a background of building systems at scale. We work with all the national laboratories, that's an overstatement, with many national laboratories, including Argonne National Lab, where I also have a position there to look at these kind of problems at scale. It's kind of like this is where I come from, but in the last 3 years or so, I'm also very hands-on. I code all day. I like developing technology, and I've been doing agents for at least 3 years now, before it was even kind of popular and sexy. So I'm sure all of you follow some sort of a spectrum of adoption. Maybe just for the fun of like getting to know the audience a little better, maybe you can put on the chat, like where are you in this kind of spectrum of adoption, right? So we have, I can never use the AI in my life, or like I don't want to do anything around AI, all the way to kind of orchestrating a bunch of agentic workflows and deploying them in production. So there's a big spectrum. So please put it there as like just like a survey, if you will. But the reality is what I'm trying to get at. It's a big spectrum of AI technologies, right? So we're seeing this progress so fast. And we're transitioning almost every 6 months to kind of a new paradigm of AI. We started with the typical chatbots. The interface is very, chat-oriented. Human interacts with AI back and forth, a multi-turn chat style interface. We moved on to kind of Copilot era, where you see products like VS Code or other like software that we use to do our job every day, like kind of plug in to this kind of like ecosystem of AI. And honestly making a slop out of AI, like just putting this thing everywhere and just makes things worse than we want to. And then in 2025, it was the age of the year of the agent. And as you see at the end of the year, more and more from the industry, as well as maybe limited academia, but also academia, we're kind of moving towards this multi-agentic, multi-AI kind of system that can almost operate at the boundaries of autonomy. So I'm not going to presume you guys do not know AI or you know everything about AI, so I'm just going to cover all the basics. What makes AI agentic? And so I like to kind of teach this to the classes, like, there are four main components, right? Like the model or the brain of the agent, if you will, and then you have, tools, the prompt itself, the system prompt, the tools, the set of tools, and the memory. So a perception layer, in a way, through sensors and data streams, a reasoning kind of like capability, like with more and more the chain of thought models and other kinds of reasoning models, the tool use and the whole computational actuators, how can you just connect to the environment and to the world, and then what can the agent learn, what can the agent remember, what can the agent kind of like repeat or reproduce or even codify into predetermined reusable kind of pieces of prompts, if you will. And so we see more and more emerging autonomous research systems in the literature. I don't expect any of this to be production ready, so you can just go and download any of that and just play with it and have a full AI scientist. But at least the direction is there, and there's limited, I'll say, bibliography at this stage, but more and more growing around this concept of this co-scientist or some sort of a virtual lab or something where humans are steering these AI systems towards autonomous discovery. There are some early proof from this. The Google AI co-scientist paper kind of like proven that a lot of the stuff that they used AI for kind of compressed the generation of hypotheses. I mean, marketing, years to days and all of these fancy things. But we see the government also investing. You guys are a community, deep in science and in this kind of tooling. So, you know more about the signal from the federal government and the directions there. But, also industry, they all launched dedicated programs for AI for science, and that includes all the frontier labs and cloud providers. So the signal is clear here. We're moving towards this multi-agentic and autonomous like systems that can kind of manage certain amount of work. And what's clear, at least should be clear from this talk, is that these systems succeed or fail based on their ability to access, understand, reason, orchestrate, and move the multimodality that makes scientific data. And so, I come from a systems world. We like to build systems to support scientists like you and solve problems you guys are facing at bigger scales and things like that. So I think we need to pivot and shift the infrastructure from a storage-centric, human-centric kind of paradigm to more a context-centric approach. So my thesis here today is that context quality, not model size, is what determines whether the AI system will succeed or fail in the task is doing. So what we traditionally built on and upon is like systems that target humans, obviously, like, parallel file systems for bulk writes and POSIX semantics to argue about, consistency of data and batch schedulers and all kinds of interesting middleware. And we had hierarchies, like, as I said, most of our prior work was kind of taming the complexity of an N-tier hierarchical storage backend. And so, however, what we need, that was a strong however, what we need for agents is think of it as a higher level of abstraction of what the data means in a way, We need real-time context assembly, like what is this scenario or the environment the agent is deployed and operated upon. Semantic data discovery, like it's not enough to say, here's, I have all these file names and all these folders, and they're curated and managed by this, I don't know, library in the parallel file system and whatever, it's one doing. But we need more of what does the data say, what does the data represent, and better discoverability around that. Dynamic tool orchestration has been shown that agents can handle up to a certain amount of tools. It's understood that you can't just give the entire set of human tools to an agent and expect magic, right? Like we have to figure out that every tool at the right time, at the right task. And finally, adaptive memory management, because again, one thing that defines these AI models is kind of like the non-deterministic transformer-based kind of nature, where things can kind of evolve, and sometimes you have a lot of things to store or to retrieve, and some other times you don't. So, as I said earlier, there are some initial evidence that supports this thesis. This study from Google was also validated by Imperial College, and they showed that the model was not the bottleneck. More likely, it was the context assembly that led to better improvements in the base model capabilities. So, with that kind of intro to the topic, I'm going to just lay down 3 kind of steps of the talk. I prepared for 25 minutes roughly, but feel free to stop me and ask any questions, and we can even jump on a terminal and we can play around with those agents. So, part 1, I'm going to kind of set the tone of where are we today and what's the infrastructure again. Again, I'm biased, obviously. I'm coming from the infrastructure perspective, and how do we build systems that scale and support a diverse set of applications. In this scenario, our job kind of moved, as I said, from serving the human user to be able to serve the agents that serve the human users. And so for that, we can see a paradigm, like a paradox. Everybody back in the 2015 to 2020 or whatever, even more, they were talking about this big data era and all of these scaling and massive large data sets. And you guys are the best here to know about these problems, and you revolutionized formatting stuff around your science. And so this is not new. However, when we see at the same time is that AI is starved for data. Like there were times in the news that you hear AI companies are running out of data and things like that. But this is the paradox again. I think we there is room here from our perspective, from our science, the domain science, storage, and data management, to expose safely and easier and get ready this data for AI kind of assisted processing. So where are we today? As I said, we have mostly batch-oriented systems, which is great for the paradigm we used to work, or at least things are still like this, but the trends are clear, as I said. File-based access, which it's still remaining true in the AI space. You see more and more AI kind of agents talking to one another through a file. Like, the best example I can give you is if you guys have used, terminal agents and AI, the Claude.md or agents.md is one example of file-based primitives around human and AI or AI to AI. But there are better, of course, paradigms and communication protocols between agents and agent to agents and things like that. We also have a static storage. Like, usually, you provision a machine, you talk to your scientists, you're what kind of requirements would you have? You call the vendors, you buy a really big supercomputer or something, and then you're done. That's your static storage system for the next 5 years until the machine is decommissioned. And so that's okay, and it's typically provisioned based on the profile of what you guys are running or each institution is running. That is not a good solution overall, and it's very slow, and it's very specific to systems, and it typically leads to vendor lock-in, and you have to follow whatever the companies are, who sell this stuff are telling you. But in reality, what we said is real-time orchestration for agents, data continuously streamed between phases and between agents. We want to build up context assemblies, like think of them as pipelines of stuffing the context into the memory of the agent. Think of it this way, and then optimize for latency, obviously, because you don't want to have agents like waiting or doing their own thing. Both of them are equally bad. Context-based access, we're looking at developing also like new kind of types of data models that bake into the data pathways, the intent of either the user, the human user, or the agent user of the system. Again, think of as a storage system, data management. Who is your client really? Who is interacting with the data? And finally, dynamic adaptation. This refers to traditional techniques like even prefetching, and how do you do that in the agent space? And of course, specifically related to the model performance, right? Like prompt caching is big. Most of these agents are really working well because they hit the cache so often and they can kind of loop and iterate. So prefetching kind of breaks those things, and so there's a lot of interesting stuff to adapt into these agentic-driven steering, if you will, of the phases of the workflow. So what's the problems around this context? This bundling together all this kind of context and presenting it into these agents. So I'll try to classify, but most of them are they may be close, but not really. So context poisoning, it refers to bad data that cascades through agent workflows. So think of it again, if you have multi-agentic workflows and you're prompting the first, some agent at the beginning of the DAG, for instance, and that agent maybe hallucinated something that gets fed downstream to the other agents. That's usually context poisoning. It's not just agentic context poisoning. Humans poison the context all the time. If you code it with AI in your editors or whatever you're coding, you probably have seen behaviors where you're changing your mind as you're going, and maybe you're like typing like crazy, all these instructions. No, you should do this. No, you should do that. Again, eventually you're polluting the context. Context rot means that while you have good data in the context, that you were curating this context, you were curating what goes into the context window. By the way, I'm not sure you know, but let me do this. Let me try to visualize a context window. Okay, so let's zoom in this. Let's zoom all of that. And let's start Claude. And I'll make him do something. Let's look at the context window in the beginning. So you'll see how, this is one agent. It seems to be the leader agent right now, but most of them work the same way. And so you see here a visualization of what is this? So we have a context window of 200,000 tokens. That's what you can stuff into this agent. Like you cannot go more, like the agent will not have no space. And so part of this context is already utilized. I just spawned the agent. And as you see, 30K is already used out of the 200K tokens. By the way, one token is three quarters of a word, roughly, of an English word, roughly. But so you can think of you can fit here 150,000 like words, maybe half a book. Okay, and so what do they have inside? It has certain different things that come built in with the agent. So it has a system prompt, it has system tools, it has MCP tools. In this case, I'm keeping it relatively lightweight, but not really, because I was developing a website earlier and I had to have a specific MCP tool there. Custom agents, memory files, skills, and then messages, like when we talk to it, right? And then there is a little bit of a product-specific something. This is the compact buffer Anthropic is using to compact this context if needed. Think of it as a summarization. They're passing the entire context into another LLM, and they're summarizing all of those tokens, and they need a little buffer space there. I deactivated this feature to get back my tokens because I want all of the free tokens to code. And then also you can see how much each one of them is using the tokens in the memory window. You'll see your custom agents that you may have. You see different plugins you may have, the memory file, and all the other skills you may give the agent, which seems like I have enough skills here. But that's kind of how it looks inside the brain of an agent, right? So like you're feeling things here. And as you're chatting with this, let's say I'm going to give him an init command to kind of go and read what I have in this project and what kind of files and what kind of context it can collect. And you'll start reading the context. And we'll come back and see how the context window was filled. So why I show the context is to visualize for you what is context poisoning, what is context rot. Like even if I gave good data in the beginning in the context window, it may lose value along the time. It could be time sensitive. It could be all kinds of things. Context clash is when valid data from different sources contradict itself. Like maybe a typical example like Kiev is like, two papers report opposite findings, or you're using two libraries in your code and maybe one is version 3.7 and the other one is the new one, 3.8. And both of them are, let's say, a specific library, but maybe the docs or the API even changed. And so you have context clash. And then finally, context overflow. Like, what do you do when, well, this 200K is not enough? And then obviously you have to think harder there. Like when the context window fills up entirely, let's see what he's still exploring. But he's doing an interesting thing here. He's using an agent to explore so he can maintain the token window clean on this specific session. So what does that mean? That means you can have multiple context windows working together on the same program. And so before we jump into that kind of multi-agentic context window management, let me probably define first this memory problem in a way. So what memory distinguishes what makes a bot, like a chatbot or something, from like an autonomous agent. Different types of memory for science. I hope I'm not boring you. And
you guys going to?
Hello, Corey.
Oh, rental car shuttles.
Okay, probably something else. So I'll continue with memory types, but please, if I'm losing you or you have questions, like stop me and maybe I'll go slower. There's quite enough of content to cover. So memory types for agents. So that would include episodic memory. So what kind of experimental events, sensor readings, or other multimodal streams. Semantic memory, which is, again, domain-specific, first principles, causal relationships, things like that. Procedural, which is, again, what did we learn from workflows before? What are the instrument protocols? What are the given APIs you should use? What is the environment? And finally, some sort of a working memory, which again could be from gigabytes to petabyte scale scientific data sets, like dumping an output of a simulation to AI. And of course, that's not easy to do, as we talked about. So there is in the industry quite a lot of kind of frameworks and such a buzz. Like every week, there's like at least 20, 30 new agentic tooling. And I mean, I'm responsible to it too, but we're developing a lot of them too. But my point is, this is a very active space, and if you were thinking of what to do next, join on that space. This is very active, very beginning of everything. There are some kind of early kind of movers in this space, like Crew AI and AutoGen from Microsoft and LangChain. They have like a LangChain index and LangChain graph and LangChain agent and all kinds of stuff. Usually those are awesome and more commercial, if you will, or more developer, if you will. Most of them are built in Python or TypeScript or things like that. Good luck like integrating them with like Slurm and some sort of an MPI cluster and things like that, right? So there is room here to see what the industry is doing, identify gaps, and potentially build something more on our scientific constraints, right? And what makes science different from enterprise data or commercial, I'll leave it up to you. You'll know better why scientific data has to have a special kind of treatment. Now, the core problem is beyond the optimal context size. You see agents kind of like repeat failed actions, like even the same agent, the same model, the same prompt, and or like tweaked prompt, and you'll still see agents, may call tools and they may fail. But I mean, besides the beauty of being able to recover from those errors, it's still wasting compute, right? So too many tool calls cause systematic failures, unbounded memory accumulation degrades reasoning. I'm sure maybe all of you had this experience of like when the chat gets too long to the AI, the performance or the responses are really, really bad, right? So usually a fresh context window or a fresh chat session usually fixes these things and brings back the AI to like a normal mindset. And finally, the scientific agents may need physical constraint awareness, like what is this, instruments and accelerators and microscope, telescopes, all kinds of specialized sensor data and sensor instrument stuff. Someone could argue, do we see a world where all your NOAA sensors around the oceans are just agents? Maybe managed by agents, autonomously going around and measuring things and reporting back to humans. I mean, it's clear that things are going that way with drones and things like that. Provenance tracking is super important, right? Like you want to be able to kind of come back and even like rewind and, play it as a cassette tape. Like what happened? What did the agent do? Where do things go wrong? And this is a little, a contradiction again, because even the AI community sometimes is, they don't really know exactly why the neural network is activating specific, regions in a certain way to produce the output. So this explainability of AI and particularly agentic provenance, because even if you don't care how the AI came up with an answer, you still want to keep track of what the AI is doing. And this is directly correlated to the autonomy of an AI agent. It's proven that the more, the boundaries of autonomy is getting pushed forward, the more you need like some sort of techniques to argue about the correctness of those steps. Like, so right now the holder is, I think, Opus 4.5 from Anthropic that work for more than 35 hours on the task, autonomously with no human supervision. There are other ways you can hack that behavior. I mean, maybe you guys know the rough loop, maybe you don't, but this is like some sort of like, think of it like an infinite loop where the AI at every step of the way is just doing something. Like, goes around and is like, now I have nothing to do. What else can I do? Maybe I'll just polish this thing or fix this thing or fix these things. And so you can make the AI work for weeks. In fact, Anthropic did it, one of the frontiers, and they for fun, for a whole week, Claude was building a C compiler. And while not competitor to CLang or like GCC or any of that, it's still working. And so for a whole week, it shuffled more than like 100 million tokens or some crazy stuff like that. And it just eventually figured out how to build a compiler. So that's what's happening today. I'm talking too much, but part 2, let's talk about context engineering. And so the term itself is kind of like vibey and kind of like trendy on Twitter, stuff like that, right? Like, but it is true. Like, it's the discipline or art or science or whatever you want to do it, or hackery of designing and building dynamic systems that provide the AI agents with the right information, the right tools, and the right context at the right time. Like Andrei Karpathy, one of the most prolific coders in this AI space, has said the hardest new programming language is English. And at the February 2026, this could not have been more true. It's absolutely insane, the times we're living in. But again, I think the message I'm trying to pass here is, our traditional data management pipelines are more like, store this thing, we'll figure it out later, maybe we log everything the system is doing and we'll figure it out later. And then most of the time, 90% of data, they become dark data, never touched by a human. And so we're data hoarders, but we never really moved away or broke the spell away from how do we take advantage of all of this data, right? It's very passive and it's very human-driven. Now, with this context engineer, we're trying to push forward with like developing systems that are more active and they're taking action in the background. They're understanding, they're perceiving the world around them. Like when I say the world of an agent could be different endpoints and APIs and different tools you can interact with. And all of that, why? Why? Because you want to orchestrate like the context that goes in and out the inference endpoints. And so long-running agents accumulate massive token counts. Scientific data is inherently multimodal. Like nothing is just text or numerical data. Like it's a mixture of things, and actually complicated mixture of things. Like let's be honest. Like it's one thing to go to Gemini today that they claim to be the best AI for multimodal stuff and just give it like a picture and maybe a description of what you want to do, and then it understands both the picture and the text. But is that enough, right? Like when you want to pass simulation outputs and sensor data and different granularities, different dimensionalities, and all kinds of things. Generic memory systems will not work well when we have domain specificity. Like, think of the complexity, what you went through. And I mean, I'm kind of biased with HDF5. I work closely with HDF5 for a long time now. We have contracted them to develop some of these technologies together with us. And so the physical units like, accuracy and all of these things that they're really important for us and for our experimental processes. And so that's not necessarily something that has been looked at by the enterprise memory systems. Context window overflows or costs balloon, just to give you like a frontier model today, costs like $15 a million tokens on the API. Million tokens is not that much. It's like 20 minutes of coding. And so this needs to be managed, right? Like this is not going to be deployed at scale. And there are some sort of studies out there, and I mean, maybe unpublished, maybe anecdote, maybe empirical stuff that proves. That proves that the memory and the tool and the context entity is improving significantly agent search in one case or agent output in other cases. So I like to kind of break down all of this context into 4 simple things, if you will, 4 operators, if you will, like we humans or the agent itself will kind of utilize those primitives, if you will, and we can argue about those, I think, in a better way. So one is right context, right? So like we talked about this guy here with this context, which is he done? He's done. Let's look at his context now. So obviously, we'll just see a little difference between the memory. There you go. Now we have a bunch of memory messages filled up in the context window. Because the agent, as you see, let's go up here. He explored. He used 26 tools. He used 86,000 tokens, passed that to the main agent, which is the one we're interacting with. He read the files. He read other files, and he's like, now I have the information needed. Let me create the clone file. And then he went and generated more tokens. And he summarized here. So all of that work is inside here. Now you can think of this. This is your valuable context. This is what holds right now the AI, and the AI session here is valuable or not. So should you want to keep that context of the AI, boom, you want to understand that you may need to write externally, like be able to write context outside, right? Like the agent memories, the agent tools, whatever you want to do. The other one at the same time is the opposite, like, read and write in a way. You want to select, you want to retrieve only what's relevant. There may be, techniques there, including RAG. Maybe some of you heard of this retrieval augmented generation RAG. semantic similarity things, time-based retrievals. Again, think of like, okay, if context is relevant on a time series situation, could I not have an auto decay thing that kind of auto trims the context as the moving? That doesn't exist today. If that's something that you're doing in your application, build it and release it. Compress. This is the logic of like, can we take a bigger like exploded context window and compress it? And compressing a context window is not as equal as data compression. Okay, there may be more interesting things you can do. Obviously, the context window is representing a variety of content. It may be textual things, it may be results, it may be inputs, it may be tool calls, intermediate steps. No matter what, there is this need at the end of a session where all of this is full, you want to compact, you want to summarize this context. So compression techniques around context, and you can think of a million scenarios here, like a token budget, where you give it the AI, you have 1 million tokens as a budget, achieve the most work you can do, and here's your compress function, so you can keep compressing your context window and keep going forever, autonomously anyway. And finally, the isolate thing here, where you partition the context outside of your window, and you kind of give away well-defined tasks to other context windows, right? So an example was here, where we ask it, what's up with this project? And instead of the agent, where is it? There you go. Instead of the agent doing the exploration, he launched a new agent. He will launch this explore Sonnet 4.5 subagent. This is the model of power that subagent that ran for 2 minutes, consumed 85K. But as you see, I didn't use 85K inside here. So it isolated that context into the agent, and boom, this window is still clean. Now I can kind of go back and forth and talk to this window to do this specific session. The agent here, obviously, got back some version of a response from this exploration agent, right? And it didn't get back all the 85 tokens, 1,000 tokens. It just got the basics. So that's a form of like isolation, and even like a compression. Is a lot of these things are expressed in these 4 things. Okay, I think I touched a little bit about that, what makes it challenging. I think orchestrating the data and the metadata and the telemetry of the environment and the computational state we're at any given point is critical for scientific agents when you want to give precise context and allow them to perform autonomously. Challenges and complexity, I think I did mention a little bit. There's multimodal data, and even the speeds, sometimes sensor data, like have really high streaming speeds and things like that. And then the hierarchical importance as well is very critical here. So you have active experiments, you have current hypotheses, you may have historical information, you want to correlate, you may have some working data set with intermediate results. So there's a lot of interesting importance within this context window, if you will, right? Like it's not just the oldest stuff get out. Like it's really, really hierarchically important to classify all of that and evict or bring valuable context into the window. So is there anything here? Blah, blah, blah. Semantic understanding before. Yeah, okay, sure. So even if we get to that point of, okay, now you build me this context and I pass it to the agent, and then, okay, so how do we argue, was that right or wrong? And how do we build evaluation frameworks? What time is it? 12:42. Around all of this. We call that, the lineage of context, and you should be thinking of what kind of validators we can put in there, what kind of models or other AI agent systems that help evaluate and capture trust. I mean, not trust, but errors, so we can build trust to these systems. As of today, I don't think any of us is trusting them to do our job autonomously, fully. Okay, so what can we do? At least what are we doing? And as we're building some of the technologies in the lab, in the research center, we learned a few things, and so I hope I can convey them correctly today. First thing is, I want to bring to the highlight here that there's a lot of effort in the community. And maybe you're paying attention to the news, but trillions and trillions of dollars of freaking investment, and the market is crazy, and investing in even like a simple person can get like $1 billion funding now. So in that crazy world, though, there are some protocols, there are some emerging standards. While they came from this kind of googly OpenAI world, it doesn't mean that they cannot be adapted or adjusted, or we cannot bring the HPC flavor and just sprinkle it on top of those protocols. One is the MCP that I heard Douglas say that you guys are looking into it, and of course we looked into it and all of that. And I mean, I think at this point, I think is well known, supported for many surfaces. There are plenty of limitations around it, and I can talk for hours about it, but let's move on. Agent-to-agent protocols, again, developed by Google, donated to the Linux Foundation. Now it's available in open source. Agent communication protocol, agent client protocol, agent comments protocol. You know how the industry is going crazy, that they're allowing the agents to be able to shop for you and book whatever. Like, we don't care about that, but when you're building multi-agentic systems, it could be that you want to communicate between agents. Think of scenarios like from the MPI world, like, you know, gather, scatter, and broadcast, and things like that, that they're not necessarily part of the protocol today. But that's why I keep calling people, hey, join this, build things, contribute back to the protocols. I think it's important to support protocols like these, open source protocols, to prevent one or two companies controlling the space. I think it's also wise for long-term viability. Okay, a little plug. So what is the CLIO Kit I'm showing? I haven't introduced this thing, but this is the main project that, let's say, I wanted today to kind of highlight, is this IOWarp.ai. I do have some links here for you if you're interested to go kind of check out the IOWarp.ai site, or we have this other like MCP tools. We have a bunch of features, MCPs, and all kinds of things. And the documentation is available at docs.iowarp.ai. It's still an academic project. Please be kind to us, but use it as much as you want. This is my plug. It's coming up for my new release in April, in beginning of April. There's a lot of people working behind that. A lot of engineers and a lot of PhDs are doing their thesis on top of this platform. What is it? It's a platform. It's it has a lot of like engines and things like that. I'm not gonna make it a sales pitch here, but effectively what we learned from this is that a lot of these problems I talked about earlier is the summary of this kind of thing. So in IOWarp, we have the context layer for input-output, the CLIO. CLIO core has 4 engines. Those are like the CLIO ingest. Think of it as the way in. Here's where we build like an assimilation engine that supports a lot of input formats. It normalizes them. It assesses the quality of this input and the signal. And we're now adding semantic enrichment using like smaller like AI models, like fine-tuned to be able to describe this kind of ingested data and enhance them semantically with descriptions and meta descriptions and summaries and things like that. Then you have the mover, the CLIO transfer engine, which it's kind of like our main bread and butter in the lab, where we have developed a lot of IP around this. How do you manage storage tiers? How do you move up and down data? How do you stage print before the program starts? How do you evict things out? How do you support like from GPU HBMs to, you know, specialized hardware like DPUs and NPUs and normal hardware like NVMe and SSD and all of this kind of stuff, right? So the mover is doing a lot of this context. As the context gets created at the ingestion layer, then the mover is moving it around the cluster depending on who is requesting it, what kind of program and agent and thing is requesting it. CLIO Explore is the query, if you will, interface. It's, of course, it's natural language. You just talk to it. I mean, obviously, at this stage, everybody is happy to have a natural language interface. However, it's not as empty as, oh yeah, I'm just chatting with this bot. It's interesting to see how do you develop this true multi-agentic systems, right? Like when the human scientist comes in and types something or puts something on the prompt, then you have to be able to detect what is the intention here. And so what kind of model should I use? Should I trigger my big world model, like a really expensive inference? Should I trigger like a tiny specialized model? Because what the intent here implies is that we need to have like a short task or a quick response. Or there's a lot of interesting stuff even on the interface of natural language, and we keep developing them with multi-agentic systems now. And then the CLIO plugin is kind of like the connector. We have built like a whole like integration layer with the rest of the platform. Think of them like Slurm MCPs and all kinds of other interesting backends to support. And now we're adding execution sandboxing, because one other thing you don't want to do is have agents just flying around on your machine without some sort of a isolation, if you will, or seems like containers are winning right now, because you can just dump an agent in a container and just set up your permissions and you're good to go. Now, what did we learn from kind of like the activities the last like 6 years around all of this stuff, and particularly intensive the last 3 years around this stuff? Data wrangling across formats, this must be automated. I don't see a world where it makes sense to have all of those communities and, have HDF5 and NetCDF and GSCN and, I don't know, Silo. And I mean, the list goes on and on and on, right? Like this was for domains and for humans to make sense of how to organize the data. Not anymore, right? Like I feel like this needs to be automated in a way. And even have new formats that are agnostic to humans and more optimized for agents. The format conversion must be abstracted, and the tool coordination must be orchestrated. And finally, this quality validation needs to be a continuous thing, not like an afterthought, not like a one-time thing, but more like a continuous thing. It's like, so what's hard, it's still like the multimodal unification, right? Like so that there is no clean, at least it's elusive right now, maybe we'll find it, but no clean abstract solution of like representing all the diversity of data into one unified data model and then build up on that with modules and specialization. So there's still room there. It's not just a format conversion, by the way, it's richer than that, right? Agent memory needs domain awareness. This is not just a conversation chat. This is not like, oh, just keep your chat. This is more like what the agent learned, like what the agent distilled by calling 100 tools and making some interactions with the environment. Reproducibility obviously is nowhere to. I don't want to say nowhere. We, the communities of scientists and DOE and NSF and things like that, are trying really hard, but it seems like the industry is not really particularly aligned to align the AI systems. We'll see. Hopefully, everything gets sorted out on alignment, but that's important too for reproducibility purposes. How do we even know that the AI is not lying to us? It's a simple question, right? Okay, so what I believe, this is my bias comes in, and I'm wrapping up. I have 2 more slides. Is that what human like hypothesis generation? Yes, there are signs that AI is starting to produce original science and original hypotheses in very tiny domains, very tiny math and physics. There are 2 papers out there, again, that the community agreed that the AI did in fact hypothesize original things and proved original things. And it's still the beginning, but if we're doing it in December 2025 with the speed of evolution of AI, I can see January 2027 having an AI conference and having agents submitting to AI conferences. And we humans are just a steering committee. I'm being a little bit dystopian here. Let's move on. Creative scientific insights. I think that sense of us being organic and 3D and experiencing the world is building into our evolutionary process and creative thinking. And it's not creative only when you do like art, but science has a sense of art, and I think humans may stay unique there. Ethical judgment, the AI systems don't care. This is all human-driven, societal impact. I think we still need to think hard through there, and some sort of research directions, right? Like say we have AGI in 2 years. I'm envisioning in my head is like a powerful like laser gun. The question is, where do we point it to first? Like, what is the research direction and priorities for these powerful AI systems? Okay, some research gaps to leave you with maybe open-ended questions here. Dynamic schema evolutions, data that change on the fly. Again, you guys are experts with scientific formats and how things are changing across modalities. Valuation and trust, how do we measure context quality? How do we measure agentic output? Do we always need to have human in the loop, human verifiers? How does this work? Scientific reasoning, I'm putting that there because we don't only want to do pattern matching, like, here's the literature review, here's blah, blah, blah. Like, it's literally, how do you think as a scientist? And finally, bridging the two worlds, that AI needs compute, and HPC traditionally is the provider of this high-performance computing. So bottleneck is context. Context is the bottleneck, not necessarily today's models. 4 failure modes define the problem: poisoning, rot, clash, overflow. I showed you some of the context primitives like write, select, compress, isolate, and we talked a little bit about the protocols used in this research. And here's all the links you may need. Thank you for listening. I'm open for questions. Sorry, I went too crazy with all of it.
Thanks, Sunny. That is great, and I'm glad we had a recording. And we are short on time, so let me see if there are any questions people want to raise at the moment. Otherwise, we can also collect questions in a shared Google Doc, and then we can iterate through the Google Docs that way.
Sure.
Okay. See any questions people want to raise, either via chat or raise your hands. I saw some hand clapping.
Okay, thank you, Rob.
There's question from James, or like comments from James, thinking about the context window in a way that's more like a file size limitations. So is that good analogy for thinking about context window for people who are not super familiar with the agents or not using agents quite day to day?
Yeah, I'm sorry. There's a question there because I kind of lost the question.
Yeah, it's not. It's more of a comment, but I guess I'm not hands-on agents yet, and
yeah.
But I do use Gemini heavily, and GEMS. I've heard at least the vendor refer to. They kind of interchangeably use the term agents and GEMS, but they developed this GEMS as part of the LLM, and I just thought that might be an analogy because there is a file limitation. So I was thinking that in terms of token limitation. And then I just wanted to verify if I'm thinking of this correctly. And then like if I set up a gem with detailed instructions and files attached to it, it's very hard to go beyond the topic that I introduced in the gem. I have to open another window, like just a regular chat window, if I start going beyond the repeated task that's in the gem, because it'll keep like bringing back information that I don't want it to. And I was wondering if that's a good analogy of context window.
Yes and no. Yes, the context analogy is right. Like as you're chatting with this Gemini chat app here, like you can see as the conversation grows longer and longer, the Gemini may be forgetting things. Maybe you have to repeat yourself saying, but we agreed we're going to do it that way. And why are you forgetting this? So that kind of part is because you know what the chatbot is doing? Google is compacting your conversation in the background. This context compress I said, it's summarizing everything you talked about up to that point. You don't know what's happening, and then the AI seems dumb. So that's one thing. GEMS, however, are not an agent. GEMS is more like your projecting or injecting your custom user prompt, like system instructions, and you're making the AI behave based on your custom system prompt. Like system prompt is more like the constitution of the AI. So GEM is a way from Google to create these kind of fine-tuned personalities of Gemini. And it's the same for ChatGPT. They have their own, how do they call them? I don't even remember. There you go, GPTs. And so you can create the GPTs, I created like a text humanizer because they're doing a lot of, LLM language. And so that if you look at this and you edit it, yeah, it's what you're describing. You have like some sort of a name, a description, and then the titles, this instruction set, right? Which can be as big as you want in your Gemini and in OpenAI as well. That one is what makes this conversation with ChatGPT different than the normal chat window, which is, if I go to a chat new window and I chat with this guy. Or with this guy, it's the same thing. So gems are more like customizations, a version of an agent. If you're using Gemini, I strongly recommend you go to Gemini CLI, which is going to be your same Gemini, just run it on the terminal. You open on your project you're working on, write Gemini. You need to install it, of course, first and log in with your Gemini account. But then you're going to get like an interface, like a chat interface, as you see here. Now I have a terminal agent. It's not a chatbot anymore. This thing can work for me. I can give it a nice prompt and it can go crazy. You can go call MCPs, you can trigger skills, you can do things way different than what the chatbot can do. Even though the chatbot, they added some versions of agents, like a deep research option is an agent. A deep think option is an agent. So there are multi-agent stuff now inside the chatbots, but effectively the chatbot is not an agent, okay? I wanted to clarify that.
Well, thanks, Anthony. We are going to do one more question from Corey Levinson, which
Absolutely,
is asking,
Corey.
what are the ways you are looking at integrating semantic data modeling into this work? I mean, for the IOWarp, and any tools that have been useful for you?
You have to talk more on the engineer. Maybe he's on the line, Joe. I don't know, but we have looked at the commonly used formats right now. Like we support POSIX, HDF5, Adios, like this kind of stuff. But semantically, to be honest, like I have a PhD student working on it and about to release a paper. It's more around. I'll work on the example of let's say of a document to just make it easier, right? So how does, let's say, document embeddings work, or chunking, or all of that? You work with like a predetermined, let's say, chunk strategy where you just take like 100 bytes from the markdown file, let's say. Let me open a markdown file somewhere here. Do we have anything? Okay, whatever. And just tokenize it by like every 100 characters. But you can also look at the markdown and say, wait, this hashtag here is making a title, this makes a subtitle. And so you could understand some sort of like block of text relationships across the whole document, and then not only embed and chunk the raw values of what the lines are saying, but actually how are they all interconnected based on the document structure. So similarly, we're looking at like stuff like that. How would be a dimensionality be related to another dimensionality? How are the attributes of a data set affect the embeddings of the values? And so there is interesting stuff there. The other stuff that's interesting is common embedding spaces, where you embed both the image kind of embedding space and the text embedding space in the same one. That allows you to do better kind of like understanding of the data structure. But it's not a solved problem. I can talk for hours of techniques we tried or the industry is trying. It's not a solved problem. I think we need more help. This is a call to action.
Right. Thanks, Anthony. I think we have to end it here. And I encourage anyone who have questions for Anthony, just add them into the Google Doc that we have for the meeting notes. And I will make sure Anthony get all those questions, and then you can check the response Anthony have for you. Thank you again, Anthony, for the presentation.
Absolutely. I hope you enjoyed the talk.
Right. Thanks.
Have a good one.
Right. Thank you everyone for joining today. Unfortunately, we're running out of time today, and I will send an email follow-up with the notes and also the next steps for the cluster on the checklist too. Right. Thank you, everyone.
Thank you. That was great. Thanks.
Have a good one. Where's the button?